Welcome to our talk. My name's Steve. I'm working at Deloitte Digital.
My name's Lee Mannis, and I'm part of the Melbourne team. Steve's up in Brisbane. We're part of a team that, a small team inside Deloitte Digital that uses Unity a lot. One thing that we're really passionate about is trying to use Unity for installation work. So Deloitte Digital is a digital creative consultancy. But we like to think of ourselves as a team of thinkers, makers and doers. So we do a lot of work in Unity 3D, and the team that we work with is 3D artists, game designers, we've got producers, developers, and a bunch of really smart creative people. But in the wider Deloitte Digital, there's a lot of skills that we rely on. So there's people who are into strategy, who are into spatial design, creative brand and media. There's a lot of talented people at Deloitte Digital working on mobile, web and voice, and of course enterprise digital platforms. It's probably obvious from the name, but Deloitte Digital is part of Deloitte, so it's a global professional services firm. There's about 10,000 of us across Australia.
So as a brief agenda for our talk, we went around to the teams that we work with, and we tried to come up with a short list of things to consider when doing brand activations and installations. We've whittled that down to 18 things that will spread across design, develop, and deployment. So we'll start with a quick look at what Unity can do in the real world, and it turns out it can do quite a lot of things. It's a fantastic tool for doing installations and interactive art. We use it for almost all of our work that we do, and the reason we use Unity for these installations is the speed of development, the ability to prototype different parts of the installation, and using the asset store mostly for the prototyping stage when we want to get something up and shown to the client fairly quickly. And this flexibility is the key to this. It also allows us to use a wide variety of inputs into the software and to have a wide variety of outputs, so screens, LED walls, various other outputs that we'll touch on. And the bonus of using the .NET runtime and managed code brings us all the benefits of the .NET ecosystem.
So we thought we'd start off with a quick sort of quick range of the sorts of experiences that you might encounter out there. So these are arranged left to right, from something that's quite ambient and relatively low interactivity through to something that's more traditionally gamey. So over on the far left there, that's where you've got large video walls, which traditionally might just play pre-rendered content, but Unity's got a great role to play there in creating generative art or interactive generative art. You could be taking input through some touch, but we actually find using social streams for input is a really interesting way to get content up there. In the middle, that's a really traditional retail kiosk. So that one's in a car dealer. So where you've got a lot of content that you need to get across to a user, it could not necessarily in retail, could be something in a gallery or a museum space. And then moving up the chain as far as interactivity goes is what we think of as straight up games. So this one's full surround projection. We've got Kinect sensors mapping people's movements into it, and so it's really high touch. So that doesn't even cover things that might also sit in the really highly interactive end of things, where you might be bringing in virtual reality or augmented reality into those experiences. Unity is really flexible. It's a great way to orchestrate these items. Even in situations where Unity might not be driving the full output of everything, Unity ends up being great glue to sort of orchestrate all the physical pieces together.
So we'll start on the design phase.
Oh wait, that's me. So
we planned this well.
We planned this so well. So the first consideration we think of as once in a lifetime. And it's because while testing, you might run through something a couple of thousand times. The key stakeholders might run through it dozens of times. Hopefully you've got a really good client and they're really active in it. There's a really strong possibility that your user is only ever going to experience this once in their entire lives. So particularly if this is a game, but it spreads across all the experiences, it really has to inform the way you design.
So this is a video of Breakpoint, which was a fully immersive tennis training game that we built for ANZ at the Australian Open. Throughout the development of this, we trialled a lot of systems that would be very common to game devs, such as combo systems, streak multipliers. But in the end, every system that you add is another thing that you need to educate your user on. There's also going to be the temptation to make the game too hard. While you're making the game, you're playing it so many times. We started to get the sense that Breakpoint was actually too easy, and that's why we always use what we call disposable testers, or even Kleenex testers. You use them once and you throw them away. This way, you guarantee that the testing you get is by people who have never used it before, and that is the closest to what you'll get out in the real world with users out there. So you need to consider a wide audience. Is your installation accessible? You'll see a brief shot in this video of someone in a wheelchair, and they could play the game. But is it also fun for non-gamers, people who don't usually play games? Can they still have fun in this?
So this one's really critical, I think, for permanent installations. We say stay connected because it's important that any Unity development you do doesn't end up as a standalone item that's disconnected from the wider ecosystem of wherever it's going. That ends up being a recipe for something that's going to be out of date and get decommissioned in about 6 months. Unity happens to be fantastic at integrating with APIs. You've got C#, there's a million great libraries to connect with things. Maybe the product information that you're trying to display lives on an existing system. You really do need to build that integration, or at least take a cut of data and connect it to a source of truth. That's the way that you can keep the front end current. If there's customers who might have an existing login that's on a website or mobile phone, integrate with it and start synchronizing their data. Make that experience better. It can be challenging, but for info-heavy installations, it's becoming more and more important. So we recently deployed a series of kiosks and tablets into a retail environment, and we connected to Salesforce, which is an enterprise CRM, and Sitecore, which is a CMS. And so the idea being that you should be able to discuss something in the retail environment, then later on log on your phone or your laptop and see those exact details saved for you. People expect their experience to bridge web and mobile, and the real world has to play that role as well.
So when you're designing the product, you're not just designing the end product. If your installation is permanent, you're not just making the game, you're making a piece of ongoing infrastructure. You need to design the tooling in a way that makes it easy to build the product initially, but the real tooling should be focused on supporting the maintenance and the ongoing life of the product.
So this is from Mazda Retail Hub. It's a real-time 3D car configurator. It's out in Mazda dealers all around the country, deployed on big touchscreen kiosks. We built this with our talented partners in Spinifex and Engageus, and it lets you visualize a really detailed config and do a full accessory loadout for a car. So the front end looks fantastic, but what gives this longevity is all the tooling that you don't see. And everyone here will probably be familiar with the tooling that you build to get a product out the door. you really need to amp that up if this is going to live for a long time. So you got to try to empower your artists, empower your clients, build a proper art and approval pipeline. We've built a full approval pipeline to manage defects in the 3D art over time, to get new vehicles and accessories in on a constant basis. There's data validation and import tools, making sure that we've got all the latest product and media data across. You can kind of think of these installations as evergreen software, or as we sort of hear the buzzword around, it's like games as a service. The processes and tooling are always going to evolve over time, but spend that effort early, and you really need to consider the effort that's saved over a year or 5 years.
And this is before ray tracing. So
yeah.
Imagine what we could do now.
We'll get there.
So another factor to consider is quite often more than one person exists, which may come as a surprise to devs. As soon as you've got a touchscreen that's large enough, it will invite multiple people to use it at the same time. And the larger the interactive, the more common this will happen. So you need to consider multiplayer. Even unintentional multiplayer. For example, how will users accidentally interrupt other users, or could they even build on each other's experience with the software?
So this is a large screen interactive that we deployed with the City of Casey at a precinct called Bunjil Place, just east of Melbourne. So there's multiple types of interaction that needed to coexist in this system. You might have, we've seen a lot of young children playing around just messing with the particle field underneath. There's also a lot of info content that has to coexist with it. We knew it was going to be possible for people to interrupt other people's experiences. So what we needed to consider really carefully is what types of content is going to be prioritized, and make sure that it's really clear to the users about what's going to interrupt what. There's a lot of other ways of getting people involved. If you've got a big screen, it's going to attract a lot of attention. Using people's phone as a controller for what we think of as more traditional multiplayer games is a great option. You don't have to build as an app. Unity can connect to WebSockets. I would definitely encourage you to use browsers for that sort of interactive.
And another thing that's quite common now is embracing the physical. So you're out in the real world. How can the digital elements that you're making relate to the real space that it's in? On one level, embracing the physical is about making sure that the digital elements respond to the architecture that they live in. But it's not just in the looks, it's in the type of interaction that they have. In a more direct way, Unity is great for triggering things or measuring things in the real world. For example, using Arduinos or outputting to LED walls, motors, using spatial audio, projection mapping. There's some fantastic libraries out there to connect to IoT devices, such as talking to devices using simple protocols like MQTT.
So we're big fans of using projection mapping, and projection mapping is nothing new, but usually it's pre-rendered. So what Unity gives us is the flexibility to make things dynamic. So this is H2.0. It's a demonstration water network that's in the Deloitte office in Melbourne. If you're ever there, please drop by. Happy to show it off. So there's real water flowing through the pipes underneath this, and real flow meters that are connected to some IoT devices that were designed in-house at Deloitte, and it's sending and receiving data out to IBM Watson's IoT cloud. Unity's controlling the projection, and it's also connecting out to the IoT cloud. So the projection ends up being a bit of a twin of what's happening in the actual water network. So whenever you can mix the digital and physical worlds like that, it ends up being really powerful. You can end up explaining something in a way that's staring at a dashboard on a laptop will never really capture that.
As we mentioned earlier, Unity is a fantastic engine for being able to prototype your installation. If you're going to prototype the mechanics of the installation, Also consider prototyping the space that it's going to be in. Mock out the room, and so you can see where the installation will be. It can be really, really difficult to get a sense of how big things will be.
So that's kind of our last thing on designing. We're moving into develop, but this point actually really directly relates to the last, which is we would encourage you to virtualize the space and keep it in the installation the entire time. So this is a little grey box mock-up of ANZ's flagship branch in Martin Place here in Sydney. So we were building out the video wall there with Virtual Garden. So it's 11 metre high LED wall. But we didn't really know how big the elements would be on screen. It's really hard to pick that up when you're just staring at a small laptop screen. So we made this little demonstration. If you're making a virtual environment, it doesn't have to be perfect. It can just be a little grey box mock-up just to get a sense of scale of the place. We actually take a render texture from our main camera and we spit that out on a plane in the scene. This one doesn't use VR. This is just like mouse look, wandering around with the keyboard. VR is actually really, really handy, particularly if you have touch. So for the Bundle Place interactive wall, we built a bit of code to translate the position of someone's virtual hand so that they could touch the virtual screen, and that gave us a sense of how big the UI proportions needed to be for it to make sense to people. The last point is leave it in if you can. So while we were iterating on Virtual Garden and we started adding social connectivity, so you can tweet the wall and ask for blue butterflies and blue butterflies will appear. When we started adding more language processing in and we needed to test how it felt, we could just jump straight into the space instantly with a key combination. I think it may still actually be in the build.
One thing to remember as you're developing the app is don't make things harder than they need to be. Your priority when writing the code for this is to aim for robustness, because crashes are bad, and maintainability, because it will have a long life. Users don't have the usual route of, say, pressing a reset button or force quitting the app. You know the target hardware, so make sure you code for that target hardware. If the code's still running slow, it can be more efficient to throw more hardware at it. The extra labor time in optimizing the code will damage the budget of your project, so it's actually quicker and easier to throw more hardware at it. Do you really need to build a flexible UI that adjusts to different screen sizes? For example, you know the target resolution of the screen that you're making it for. Do you need to build a flexible UI that will adjust to different screen sizes? And above all, the show must go on. Events are at a fixed point in time, and they can't be pushed back just because the code in your installation is not ready.
So when you're out in the real world, you need to build a bit of resilience to the real world, because it's a terrible, terrible place out there. Your user will just walk away in the middle of a session. They have no regard for the beautiful experience you've designed. I'm sorry. You should always be able to go back to the attract state safely from anywhere in the thing. That can just be a timeout. You're just waiting for inactivity. Or if you want to get really fancy, we've used pressure pads in the past to pick up if there's someone actually standing there. Users are also going to try to break it. They may not mean to, but they're going to try to break it. You should try to break it as well. This is similar if you're developing a game. You want to try to find the ways that it breaks. On large screens, one of the things that we find is a lot of fingers on those screens at a time will break things. So button listeners in UI, if you're listening to something and two buttons activate on the same frame, even if you stop listening to those events, you can, in some cases, receive both events back. So you may need to set like a little flag in your mono behavior that says, well, I've already processed a button, ignore anything else. Users also don't follow the beautiful intended path that you've laid out for them. So as soon as you can get some disposable or Kleenex testers in to use, it's a really great thing to validate your UX before you ship it out there. Another factor in building resilience to the real world is it's hard not to be too critical, but it's not even about Australian internet. If you're at an event, the internet may just suck. You might have a network that's really that's got a lot of contention on it. You might have flaky Wi-Fi signals in a convention center somewhere. So whenever we're building installations, we always assume offline first. So even if we're connecting to live sources of data, what you want to do is pull all that data down, save it in a local cache, and only refer to that cache. So for a lot of content data, you might only need to refresh that stuff every 4 hours or so. With logins and everything, you're obviously going to need to connect out there. But if you do need to upload something for a user, we'd suggest building a queue of uploads and then just sending it out when you can. Unless you need that user confirmation instantly, you can usually get away with it.
Now, how, as a quick show of hands, how many programmers do we have here?
Oh, lots.
Oh, right here, and you all write perfect code, right?
I don't know why you're laughing.
Don't know why you're absolutely. Don't trust your code. This isn't unique to installations, but long-running software with no easily accessible reset button can be a problem. This is a quick list of things that we have seen go wrong. You need to clean up everything all the time. Make sure that if you allocate it, you release it. If you're bringing in lots of external content, which you most likely will be, make sure that you're keeping track of all the content that you're loading to make sure that you unload it at the right time. How many things are in charge of your game state or your application state? You don't want multiple systems trying to change state at the same time. Otherwise, you're going to end up in who knows what state. If you reload a scene, is everything going to still be there when you go to use it? Maybe it's been unloaded, or is there something that should have been cleaned up that's not? Does this work the second time around, the third, the 20th time you've loaded the scene? And if something is still listening to an event handler, that could actually prevent most of the objects in the scene from being unloaded, which is a source of one of the biggest sources of memory leaks that we have found. And what happens to when the user gets stuck?
And the user can get stuck, and it's not just the current user who's playing with it that gets stuck. If your kiosk, if your interactive goes down, all subsequent users then can't experience it. One thing that we find in trying to code defensively for these sort of installations is to build out a simple watchdog. This is a vastly simplified version, but we're just waiting for something to call that tap method at least every 10 minutes. So you might tie this to when you're changing your main screens in your application state. If you're stuck in the attract mode for 10 minutes, that's fine. It just means no one's using it. But if you end up stuck on some email form for 10 minutes, something may have gone wrong. Things will be broken. If you can clean up your own state and get back to a safe area, fantastic. We don't usually bother. We just call application.quit and rely on something on the OS level to restart us. So then we're at least guaranteed that everything's going to be up and running.
And one of the things to keep in mind that users are a very creative bunch. If you allow users to create content, that can be great for user engagement. It can also be very dangerous. Some people will always try to create those phrases or those images that I'm sure everyone has seen at various times. If they can create crude images or text, they will. That's one of the first things that you will see. Bad word filters can be a very effective tool in this. People will learn the filters. They will work around it. As I said, they're very, very creative. Images can be a lot harder to filter though. I'm not going to show you any examples. One of the ways around this is moderation, which does involve some admin overhead, someone manually looking at the text or the images before it's shown on another device or screen, but this can slow down the process. In other ways, can you design around it? For example, with the ANZ Virtual Garden, Lee mentioned that you can send a Twitter message to it to show blue butterflies. This is social media. People could send anything to that wall. You need the code actually filters out and only looks for certain keywords before having an effect on the screen, and those Twitter messages are never shown on the screen on their own. It's only showing the end result or the effect. So one of the things that's becoming popular now is AI or machine learning. Could machine learning be used for image moderation? Not really something that, or you want to be really careful when you're teaching the machine how to do image moderation. Let's try explaining that to HR.
I'm a developer. I'm not a content author. I'm sorry, content authors. Sometimes you run a little bit late. So particularly if you're making an information-based system, you need to think about where the content's stored and how you're going to get it. So you might be getting static cuts of the data. It could just be a CSV file. You might have a bunch of stuff that you're generating that's in asset bundles. The normal rules apply with asset bundles. Make sure you're only including what you've got. Even if you're running on high-end PC hardware, you don't want to have to be sending it out to 200 units at dealers around the country. But where you're trying to use live data is where things start to get challenging. So particularly if those APIs are being built at the same time you're developing the front end, we would always encourage you to build a local web server. Just something really, really simple. It could be Python's simple HTTP server. You can just run it from a line in Bash. It could be 15 lines of Node just to say, hey, when I receive a post request to this, I always return this result. Get the web API code working really, really early. Also, probably make sure that you've got the specs nailed down with whoever's actually building the API. But the theory is that you can switch to the server like right at the end of the project. So you've now removed a really key dependency from development, and it's not going to block you from doing anything. The best case is that you don't even need to do any code changes when you switch over. It should just be a configuration change pointing away from localhost and to the staging server that you're actually running on.
So now you've finished developing the installation. It's simply a case of packaging it up and giving it to the client. It's done. Your job is done. You've finished the code. It's bug-free. You're not finished, and it's most likely got bugs. Everything in your deployment planning has to make the assumption that your software will break, and also that the hardware will break too. You're not submitting the game to the App Store. You might be deploying software that is key to the infrastructure. So similar to the way that enterprise deploys software and hardware. You'll usually be deploying to PC hardware. What hardware will it be? Will parts remain available for the life of the project? Will you have spares on site? Who supports the hardware? This isn't the place to trim costs and spend less money. what operating system will it run on? We typically use Windows. That's because we know it well. It has fantastic support for graphics drivers and sensor hardware. You also need to think of the environment that the installation will be in. Is it easy to access for installation and for future maintenance? But you also need to think of ventilation. PCs generate heat over time. Heat cooks PC hardware. Don't put it in a closed box, and don't put your screens in direct sunlight. They like to go black. We have seen that. How does it connect to the displays? Many of our systems connect to multiple displays. We have 6, 8 screens connected to the one PC. Will it go through video processors? Will it be using custom resolutions? If it's a custom resolution, full screen can work, but we've had better success with a pop-up window. So it's essentially a full screen borderless window, and use the Unity runtime command line parameters to actually set the screen dimensions that you want.
PC hardware might not be the only stuff you're trying to deploy. You might be deploying stuff that's a little wackier. We've had a crack at this. This could be a talk on its own at deploying hardware in the wild, but a few quick things that you might come across that you need to consider. If you're deploying VR headsets, cable management is an absolute pain. What does the pack up and setup process look like for those things? Also, even if you're deploying something like Oculus Go or Oculus Quest soon, those things get really gross in the real world really, really quickly. Is this going to be a manned installation? Is there going to be someone there to actually keep the equipment clean? If you're deploying AR devices or just any sort of tablet, power becomes a really key consideration. So that little tablet there is one of the Project Tango devices. I worked on an installation a few years ago that was augmenting a sculpture in a gallery space. What we discovered is that the USB charging in that doesn't even supply enough current to keep the thing running. So the battery was going to run down anyway. We had to deploy a completely separate charging circuit for it. IoT devices can be really, really fiddly to deploy in the real world. The big tip that I would give is make sure you're not having to do any configuration on site. So this is usually around networking. So if you've got stuff that's got a Wi-Fi chip in it, bring your own Wi-Fi access point. It could just be a 4G access point, or it could be bridging to some other network. But that way, as soon as you've got that network adapter online, then your entire IoT network's online.
Now that you've got out to the real world, you know where it's going to be. You're going to be installing your application onto the target PC, but how do you get it on there, and how do you keep it updated? You could walk around to each PC with a simple USB stick, copy it across, and then it's done. But not all your sites will be within walking distance. Then the next step up is remote access, such as TeamViewer. You could copy the software over a remote access and deploy it that way. Or you could get a bit more advanced and have an auto updater, similar to what many apps now have. So when the app launches, it checks a remote website for an updated version, automatically downloads it, installs it, and then launches the app proper. If you go this route, you need to make sure that the transaction is solid though. You don't want any rogue software being installed on your client's hardware. That's not a good look.
And we've sort of listed these out in order, but we're certainly not looking down our nose at running around to machines with a USB stick, because in a lot of event environments, the network is just not going to be good enough to be able to deploy content there. So if you can automate it with batch scripts just to make your life easier, or a little bit of PowerShell, that will make your day go easier. this is a question that's going to get asked at some point. And it might get asked of pieces that aren't the actual Unity software that you've put together. So you need to plan early around what your system depends on. Is it connecting to video controls? Is it connecting to screens? Does it depend on web services? Does it depend on physical items that you haven't designed? You need to know who those people are, because you will inevitably get support requests that aren't necessarily in your realm of expertise. A key question that you need to ask the product stakeholders is, how long can this be down for? And that's going to vary wildly. Everyone's going to say it can't go down ever. That's probably a lie. But if you've got an hour of downtime over the span of a year, you are doing amazing. If you're doing a half-day event and you've had an hour of downtime, you've just lost 25% of the time available, and it could have been a big investment. So at those points for short-term events, consider just having a dev on site supporting it. For short-term events, that's certainly what we do, just to have that level of assurance that things are going to go smoothly and that we can hot swap out hardware whenever we need. You need to train the people who are non-technical, who might be out on site. Preferably this training is going to be really simple. It's going to be, if things break, reboot the machine and then let us know so we can do a bit of root cause analysis and figure out why it bombed out. If you can get remote access while the system is there, again, this is going to be network dependent. If you're deploying to a corporate network, you just may not be able to get access in there, or the network may not exist. But it's very, very helpful for you to be able to jump in there and be able to collect a bit of data about what's going on. Crash analytics and logs, vital. Newer versions of Unity are a bit better in logging. You can pass a command line flag to specify the name of the log file you want. The next step up from that is a service like Logly. Just send all your logs out there, and that way you can do a bit of bulk analysis. You really need to treat it a little bit like you're deploying some servers out there and see what sort of data you can get.
So now that you've got everything installed on the PC, you've got support sorted out, you need to get the application started. So when the PC is booted, there's a few steps it should do. It needs to run your app, but how's it going to do that? So you could add a shortcut to the startup folder. You could actually set your app as a shell replacement, which brings us to the next step, is you want to kill the Windows Explorer shell. This is especially important for touchscreens, because Windows has edge swipes. So people can terminate your app just by swiping from the edges of the screen. And it will also reduce the amount of notifications that you have showing up in the bottom corner of the screen. You don't want those showing up over your app. One of the things that you want to be able to do is relaunch your app if it dies. For example, we showed the simple watchdog timer before, that if something went wrong, it would kill the app. This is a way that you would relaunch your app if it dies or is intentionally quit. That could be as simple as a batch file, or you could go one step further, and we have a simple Windows Forms application that its sole purpose is to keep the application running, but it needs to be solid. It needs to launch the app. It needs to relaunch the app if it dies. It needs to make sure that app is always visible, and it cannot crash itself. So who's going to watch the watcher if the watcher crashes?
So on the home stretch, updates do happen, like death and taxes. Windows updates will mess you up. We are currently praying that it doesn't happen midway through this. During the technical rehearsal, we did actually have a Windows update kick through. So this is a shot that Steve actually took in at a retail environment in Brisbane a little while back. They haven't quite updated to Windows 10 at this stage. Another keynote there, you can probably see the GeForce Experience icon. Don't install GeForce Experience. The NVIDIA drivers are great, but if you like having random pop-ups over your installation, sure, install GeForce Experience. So Windows updates can happen at really inopportune times. So this is actually a shot from a permanent exhibit about half an hour before the official opening. It's not one we worked on, but we understand that stress, because this is sitting at about 27% complete and it's ticking up really, really slowly. So don't deploy Windows Home out in the wild. It's not what it's for. Although I will say there's hacks out there if you want to disable the Windows update. There's enterprise editions of Windows. There's various editions of Windows you can get where you get a bit better control over your Windows updates. If you are disabling Windows updates, keep in mind, if it's connected to the internet, you still do need to update it at some stage. You just need to do it in a controlled way.
One of the things that you need to keep in mind is that not only will Windows updates happen, but application and content updates also need to happen. You need to you want to schedule your application and content updates for when the installation is not being used. For example, the early hours of the morning, to 2 a.m., 3 a.m., when no one's going to be using it or the business is closed. You want to keep in mind that you don't want to show any sensitive information on the screen. If someone does see it in the process of updating, you don't want to give them any information that would allow them to attack or damage the software or the hardware. I took this photo of it's a self-order kiosk in a popular fast food chain. This was at 8:30 a.m. in the morning on a weekday, right in the middle of their breakfast rush, and you can see it's been in progress for 9,704 seconds, just short of 3 hours. So that order kiosk is not actually able to be used for its intended purpose. The ideal case for updating your application and particularly your content is to update in the background to a temporary location, and then when the installation is not being used, swap over to the new content. So it's modeled on the zero downtime model for servers. And also social media. Almost everyone has a phone. Phones have cameras. If your installation goes wrong, it shows a Java update like this one is. This is in a hotel elevator. The display wants to update their Java. It will get posted to social media. You would rather not have these images be the ones that people remember of your hard work.
So that's just a bit of a snapshot of things to look out for if you're entering the installation world. The end of that might have seemed a bit negative about here's all the things that can go wrong, but they are actually surmountable challenges, and Unity is an excellent platform to build installations on. So really looking forward to seeing more installation work powered by Unity. Thanks, everybody. And I think we've got a bit of time left for questions. Are we good?
Yeah, we are.
Yeah. So if anyone's got any questions, throw hands up and shout out. So the question was if we've encountered situations with no web connectivity. Yes. I'm guessing it's a corporate environment. Yeah. Yep. So there are potential ways around that. So you might not be able to get network connectivity through the corporate network, but some other things to investigate are running it through a dedicated 4G router, so it's isolated from the secure information. In some cases, we've had a separate ADSL line put in just so we've got that barrier of separation. So the machines that you run installations on might not necessarily be part of, so this laptop's on a corporate network, so it's got a corporate blessed image of Windows Enterprise. That ends up being a bit hard to manage for an installation, so you don't necessarily want that. But there may be ways to sort of isolate your machine from the rest of the network If you do have to be completely offline, then you'll need USB updating. You can do it. It just means that you need to ferry USBs to the technicians in the right spots.
Any other questions? I think, yes.
What's the lifespan of most of your installations? I mean, you mentioned plan for content updates and stuff. What's been your experience? 3 months, 6 months?
Longer usually. So even for event-based installations, so particularly for work that we see at auto shows, sure, it might only run for 2 weeks at a certain auto show, but then it will tour all the auto shows for the span of a year or 18 months, and then it might end up in a corporate headquarters or something like that, because they've made that investment into that technology. For retail environments, you're looking at a minimum lifespan of 3 years. So, particularly with hardware and parts, you've sort of got to plan out what is this going to look like for maintenance on that sort of scale.
I was going to say, the extension of that is, how do you plan for end of life? Or how do you force an end of life with a customer when you say, it is at the end of 3 years, times have changed?
Contract negotiations.
Yeah. So it's not easy is the answer, but it's going to be similar to any sort of platform. So it's a similar discussion that would happen if there's a key upgrade that needs to happen to a web-based platform. So we treat it like that, except if it's installed at a lot of areas, there may be a new hardware investment. But usually there's a reason why you're doing it. It's not just necessarily security updates. There's new functionality that's coming online, and so that's how the discussion usually gets framed. That to get this new functionality, we need to change the hardware or change the software.
And yes.
How's it been? Have you come across any technologies where it's almost nigh on impossible to get what the client wants? And I'm kind of referring to a job I've done recently. The Oculus Go. It's great. It's not very developer friendly in that you've got to go around all these, back doors in order to be able to get just a boot into it. It wants you to go straight to the Oculus Store. You've got to run all these kiosk modes and
We've been
things
there.
like
We've
that.
done the same thing.
We
just recent experience. I'm wondering if there's any
feel
other
your pain.
platforms you can, or any tidbits you could say for developing, say, the Quest outside of, I guess, that Oculus kiosk mode. Its own development.
Yeah, we're sort of hanging out for Oculus enterprise features because that's part of the problem. It does end up being dirty hacks a lot of the time. That's the honest truth of it. So some of the hardware that you want to deploy and what our little team focuses on is trying to take technology that's not enterprise ready. So there's not a lot of adoption of, or traditionally hasn't been a lot of adoption of game engines in enterprise, but we want to take that and use it to solve big interesting problems. So even with the hardware, you are going to have to be a bit of a trailblazer to try to figure out how to do those things. So even with those Tango tablets, so it's prototype hardware, so it was still a little bit janky. The ways that we solve it, if things are looking really dicey, is by having staff there and having a lot of spare hardware around.
Yes.
Do you guys do any paper prototyping or very before going into Unity prototyping, and do you use it with your client or just internally?
The question was if we use any paper prototyping. Yes. Unfortunately, I've removed it from the deck. There was a screenshot I had of the shape of a car window cut out and sticky taped over my screen so that we could test some calibration stuff. Typically, Unity's so quick to mock up a prototype, though, we'll often go straight to a digital prototype, even if it's just something that's built out on timeline, just so people can get a sense of how things are gonna work. Whenever you're dealing with installation technology or any technology that's going to be unfamiliar to people, getting them to experience it is kind of the only way to explain it to them. So paper prototypes have their place, but we sort of default to just building.
I think everyone's keen for some lunch now.
Thanks,
All right.
everybody.
Thank you.